Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, welcome you all to this another session on the directive effect of the substituents on the benzene ring, part 2. In previous part, we have discussed about which are the different groups or the substituents that are responsible for directing or which showing two directive effects. One is the ortho-para directing effect and another one is the meta directing effect. In that case, we have seen the ortho-para directors. These are the groups which will carry out the substitution of the incoming electrophile at the ortho or para position, where they place a negative charge at the ortho and para position, and due to which incoming electrophile will attracted at this position. Similarly, we have seen second type of the directive effect, which is known as the meta directing effect, where the meta directing groups will place a incoming electrophile at the meta position. Also, we have seen different examples of the ortho-para directing groups as well as the meta directing groups. Means these groups, when they are present on the monosubstituted benzene ring, what they will do, they will carry out the substitution at the respective places. Now, after this, just we will see the learning outcomes of this session. After this session, students will be able to explain the structure and uses of given compound, explain activating and deactivating groups. Explain structure and uses of compound. It is a different thing that we are going to discuss in this video also. Now, just we have divided whatever the groups that are available into two parts, that is the ortho-para directing and other one is the meta directing groups. Here another effect that we can give depending upon the which substituent that is present on the monosubstituted benzene, that is the effect of substituents on the reactivity. Already we know this particular part because we have seen two electronic effects, that is the inductive effect and the resonating effect, and due to this inductive effect as well as the resonance effect, these two different effects are observed. Now here you can see one column, that is the where substituents are placed, and here effect on the reactivity. Here effect on reactivity means what? Effect on the electrophilic substitution reaction, whether electrophilic substitution reaction are taking fast or they are taking at the slow rate. It depends upon the substituent that is present on the benzene. For example, if we consider ortho-para directing groups, if we consider different ortho-para directing groups like the hydroxyl group, alkoxy group, amino groups, that is the primary amino group, secondary amino group and the tertiary amino group, all these groups are strongly activating. Means when these groups are present on the benzene ring, they will carry out the increase in the speed of the reaction very rapidly. So when if these groups are present and if we perform the electrophilic substitution reaction, these reactions are taking place at enormous speed as compared to the benzene. Also, second category were alkyl groups, all alkyl groups. These alkyl groups are also ortho-para directing, but they are having effect on reactivity weakly activating. Means as compared to these strongly activating groups, these weakly activating groups will carry out the increase in the speed quite in a limited way, not as compared to the strongly activating group. Another type of the groups which shows ortho-para directing effect is halogens, but here you can see the difference between those groups and the halogen. Halogen is considered as a deactivating. Still it shows ortho-para directing effect they are showing the deactivating effect on the reactivity. The reason behind this, all halogens dominate the electron withdrawing inductive effect. Means you have to check each substituent will show which effect, whether it shows electron donating inductive effect, whether it shows electron withdrawing inductive effect, whether it shows electron donating resonance effect or the withdrawing resonance effect. Depending upon that, these substituents can be classified into ortho-para directing effects, and you will understood the effect on the reactivity. Means out of all ortho-para directing effects, majority of they are the activators of the ring except halogens. Activators will increase the speed of the reaction, while deactivators will carry out the decrease in the speed of the reaction. Now after ortho-para directing groups, we will see meta directing groups. We already know different examples of the meta directing groups: nitro group, aldehydic functional group, then ester functional group, then sulfonic acid group, cyano groups, as well as the carboxylic acid group. All meta directing groups are strongly deactivating groups. When these groups are present on the benzene ring, and if we perform the electrophilic substitution reaction, then such a reactions are proceeding at very slow speed. So here you will have to use the different catalyst or different reactions that are performed at the higher temperature. So this is the disadvantage of the meta directing groups. They are the strongly deactivators of the benzene ring. So this is about the reactivity of benzene towards the monosubstituted benzene towards the electrophilic substitution reaction, as well as the different directive effects that are observed in the benzene ring. After this, we will see different examples of the compound, that is the dichloro diphenyl trichloroethane, which is commonly known as the DDT. Here this is the structure of this DDT. What is the long form of DDT? Dichloro diphenyl. Here you can see two phenyl groups are there, on which there is a presence of the two chlorine groups. That's why it is known as the dichloro diphenyl trichloroethane. This is one carbon atom, this is two carbon atom, so it is known as the ethane. And at the second position of the ethane, there is a presence of the three chlorine atom. That's why it is known as the dichloro diphenyl trichloroethane, which is commonly known as the DDT. Most of you may have heard this particular word because this one is the organochlorine insecticide that was first synthesized in the 1874. Also, DDT is commonly used as a pesticide for controlling the insect in the United States as well as the worldwide. Even sometimes in India also we have seen in various villages as well as in cities, it is sprayed on the road, white powder that is sprayed on the road to control the insects. So that is known as the dichloro diphenyl trichloroethane. Apart from these uses, DDT was initially used to control the malaria during the World War II. Also typhus as well as the body lice. So this was the main use of this particular DDT. When the early days during the World War II, no drug was there to control the malaria, and for that purpose this particular drug was initially utilized. Due to the use of DDT, cases of malaria fell from 4 lakhs in 1946 to virtually none in the 1950. So that much effective this particular drug was observed. Farmers are using this DDT on variety of foods as well as the crops in United States as well as the worldwide. DDT was also used in buildings for the pest control because it is a powerful insecticide. That's why it is used in different buildings to carry out the pest control. Also, the reason why DDT was so widely used because it is effective, relatively inexpensive to manufacture, and its effect lasts for a long time in the environment. That's why DDT is commonly and widely used as the insecticide as well as the pesticide. Now it is not used to control the malaria because more effective drugs are available which can treat the malaria. After this, second product that we are going to discuss is saccharin. Saccharin, which is also known as the sodium saccharin or benzoic sulfamide. This is an artificial sweetener with effectively no energy, because we know that due to the consumption of the sugar, it increases the calories. So a substitute for this is saccharin, which is known as the artificial sweetener, and it does not have any energy, which is the common ingredient of the sugar-free tablets. It is about 300 to 400 times sweet as a sucrose, but has a little bitter or metallic aftertaste, especially at high concentration. Means, what is the meaning of bitter or metallic aftertaste? Initially it tastes as a sweet, but after some time you will get a bitter taste. That's why it is known as it is having a bitter after metallic taste, especially at the high concentration. It helps to reduce the dental cavities. Main use of this saccharin is it is used as a artificial sweetener. It is also used to sweeten products such as the drinks, candies, cookies as well as the medicines. But some studies reported that due to the use of the saccharin, it produces the cancer. That's why now this particular saccharin is generally not utilized. After saccharin, next product is benzene hexachloride, which is also known as the BHC. It is another organochlorine chemical variant of hexachlorocyclohexane that has been used both as a agricultural insecticide. Also, it is used for pharmaceutical treatment for lice as well as the scabies. For the treatment of the lice and scabies, this particular benzene hexachloride is generally utilized. Simple structure is there benzene with 6-chlorine, that is the cyclohexane, saturated benzene. Linden is another name for the benzene hexachloride, which is a neurotoxin that interferes with the GABA neurotransmitter function. GABA neurotransmitter is present in the brain by interacting with the GABA A receptor chloride channel complex at the picrotoxin binding site. GABA is a neurotransmitter which is an inhibitory neurotransmitter. So this BHC binds to the GABA neurotransmitter and it interacts with the GABA receptor chloride channel complex. Next and last product that we are going to discuss is chloramine. Here you can see the structure where chloramine is a derivative of the ammonia that is obtained by the substitution of the either 1, 2 or 3 hydrogen atoms with the chlorine. Various chloramines we can get by substitution of the hydrogen with the help of the chlorine. This chloramine is used as a disinfectant for the drinking water and wastewater because it is less aggressive as compared to the chlorine and more stable against the light than the hypochlorite. Now we know chlorine is most commonly used as a disinfectant, but high concentration use of the chlorine will produce certain disadvantage and or side effects, and to avoid this particular chloramine is generally utilized, which is less aggressive as compared to the chlorine as well as the hypochlorites. Chloramine is commonly used in low concentration as a secondary disinfectant in the municipal water distribution system as an alternative to the chlorination. Chloramines can be also used as a bleach, disinfectant and oxidators. Also, organic disinfectants slowly give off the chlorine, causing a slower and less aggressive disinfection as compared to the hypochlorites. Means from chloramines, chlorine is released very slowly and which will give the disinfection power. Chloramines can be also used to improve the odor and flavor of the water when chlorine is used as a disinfectant. Chloramines are also used to resist biofouling in the cooling water system. So this is about the chloramine. Now here you are having one test. You have to open your browser, go to this site, use passcode, and you have to give the answer for the